We will write a program now which is again calculating the sum of a series. Now sum of a series means, say for example I go for a series like this, say 1 square into say 2 cube, 1 square into 2 cube plus 2 square into 3 cube. I think you understand. You are already guessing what is the pattern of the series. Followed by, what will be there? 3 square into 4 cube. Is right so? You understand this? 1 square into 2 cube plus 2 square into 3 cube plus 3 square into 4 cube and so on. What should be the next number? Next term 4 square into how much? 5 cube. So this is the thing. So this is how the thing goes. So 1 square into 2 cube, let me just delete this, 1 square into 2 cube plus 2 square into 3 cube plus 3 square into 4 cube plus 4 square into 5 cube and so on continued. If I continue, then what will be the nth term? Nth term must be n square into n plus 1 whole cube. I think you understand this, n square into n plus 1 whole cube. That should be the series. Now for this, if you really look into, we can do this program. Very simply. Like we can have, simply we can write 1 into 1 plus 2 into 2 into 2 plus 2 into 2 plus 3 into 3 into 3. Now I will show you where function utility comes in if we gradually increase the complexity of a program. Say for example, this program does not really demand the need of a function. Say for example, I can write this program as simple as that, printf enter n. I will firstly ask for the value of n from the user, that is up to what term we need to continue, and you scan it maybe in a variable called n, scanf %d ampersand n. You can easily do that. Followed by, now you can go for a for loop now. For I equal to 1, I less than equal to n, followed by I plus plus, I can continue, and every time the term that is being used, if you check out, when it enters with 1, it is 1 square into 2 cube. When it enters with 2, it is 2 square into 3 cube. When it enters with 3, it is 3 square into 4 cube. So is not it I into I plus, you check out, I into I plus 1 into I plus 1 into I plus 1. Please see this. It is I into I plus I plus 1 into I plus 1 into I plus 1. I think you understand this. Please see this. I am saying it is I into I plus I plus 1 into I plus 1 into I plus 1. Is not this the term? Say it is 1 square in plus, into not, this is not plus, this is into, sorry. This is 1 square into 2 into 2 into 2, 2 cube. So you can think like this, it is, if I put a bracket, more bracket like this, it will be more clear. See, I into I, 1 into 1 into 2 into 2 into 2. Next time when it enters with 2, 2 into 2 into 2 into 3 into 3 into 3. So I think you understand this logic. And this whole thing, every time this term has to be added with sum. So sum must be sum equal to sum plus this, that is sum plus equal to this. So this for loop should calculate your sum very easily, and your only job now remains is to print the sum. Printf, the sum of the expression is. The sum of the expression is. Sum of the expression is how much? %d, and that %d has to be replaced by your variable sum. But you don't forget the sum has to be initialized to 0. So is not it better that you initialize sum to 0 over here? This should be comma. I typed a full stop wrongly. For I equal to 1, sum equal to 0. So this is how the things should continue. And this should be able to print the sum of the expression. Now remember, this is, just a minute, sorry. So now you remember one thing, that this is written without the use of any function. And this really does not need any function as such. It is too simple a program to use a function. It is too simple. When we are going to use a function, I am going to see again gradually in this program. Here you need to declare int I, you need to declare int n, and you need to declare int sum, and you need to declare int, oh sorry, n is declared already. So int I, n and sum. You don't need anything else. If I run this program should run fine. If you comment out this first line of explanation, alt R, enter n 5, the answer is 8092. You can check out, or you can do it with a smaller code to check out 3. 3 is 1 square into 2 cube, that is 1 into 8, plus 2 square, 4 into 27, plus, is not so, 1 square into 2 cube, that is 1 into 8, 2 square into 3 cube, 4 into 27, plus 3 square into 4 cube, that is 9 into 64. So this is how you can calculate that this program will definitely output 692. You can check with a even smaller expression, say 116, 1 square into 2 cube, 1 into 8, 2 square is 4, 4 into 27 is 108, 108 plus 8 makes it 116. So the sum of the expression is 116, which has been printed by this program. Right, so you don't need a function over here. It is too simple to use a function. You might think in your mind that I could have had a program for square, finding the square. I could have had a program for finding cube, a function for finding cube, and I could have called it. Yes, you could have done it, but then again, as I told you, it's too simple to do. Now suppose this program is now made a little complex. Instead of all this, suppose you are given, say, 1 square into 2 cube is there. Instead of that, suppose you are given 1 square into 2 cube. First expression is absolutely fine. Let the third term, next term be 2 cube. Please check this, 2 cube into 3 to the power of 4. Please see, 1 square into 2 cube. Next is 2 cube into 3 to the power of 4. Next term is 3 to the power of 4 into, I think you understand what, 4 to the power of 5. 3 to the power of 4 into 4 to the power of 5. The next term will be 4 to the power of 5 into 5 to the power of 6. What will be the next term? See, what have I done? Every expression is, if you look into this, 2, this is 3, this is 3, this is 4. This is 3, this is 4, this is 4, this is 5. This is 4, this is 5, this is 5, this is 6. So if this is I plus 1. This is I plus 1, this is I plus 2. So if I continue like this, the last expression in terms of n should be n to the power of n plus 1. See this, n to the power of n plus 1 into n plus 1 to the power of n plus 2. Please check this, n plus 1 to the power of n plus 2. Is not it so? N to the power of n plus 1 plus n plus into n plus 1 to the power of n plus 2. That is what it should be. So over here, your logic of I into I is gone. This is basically not I square. This is I to the power of I plus 1. Have a look into this. This is I to the power of I plus 1. And this is I plus 1 to the power of I plus 2. I think you understand. I think you understand. So what to do? We definitely now need to calculate, write a for loop over here to calculate I to the power of I plus 1. and another for loop over here to calculate I plus 1 to the power of I plus 2. Writing a for loop over here is a tough job. So instead of doing this, this will not be there. What you need to do is, you need to write a program which will be like this: I to the power of, if I write in English, simple English, I to the power of I plus 1. That is, you can write like this: I to the power of I plus 1, and that multiplied with I plus 1 to the power of I plus 2. Please see this. Is not it so? I to the power of I plus 1 into I plus 1 to the power of I plus 2. But this does not work. This does not work. This expression does not work to the power of the one I have written. So instead of that, can I have a function pow, which is I to the power of I plus 1? You get it? See, this math.h is not needed. I just get rid of this. Pow to the pow, I to I plus 1. What does that mean? I to the power of I plus 1? Is not it so? If I can write a program which will, if I can write a function which will be pow ab and will calculate a to the power of b, my job should be done. I need a function pow a comma b which will receive a and b and will output a to the power of b. That is, it should receive int a, int b and output another integer. Similarly over here, I need to calculate pow I plus 1 and I plus 2. I mean, I am looking towards a function pow ab which will receive a and b and will output a to the power of b, or rather I am looking for pow int a, int b, and to return the integer which is a to the power of b. Please see this. Is not it so? So that function must be written. If I can write that, then my job of this program is already done. I was telling you that functions are not always needed, but if you use functions in certain programs, then writing a program will be much easier. Like over here, if you had to write the logic of pow right over here, it might have been difficult. But simply to call a function is much easier. See, I could write this program in a much easier way. Now to write the pow function separately is much easy. You can very easily write a pow function which is int pow int a, comma int b, and will calculate a to the power of b and definitely return this integer. This integer is the return type. Pow will calculate a to the power of b. These are the receiving. I remind you once more, these are the parameters. The values that you send are the arguments that you send. These are the parameters that you receive. A and b are the values that you receive. After receiving the value, you calculate a to the power of b, and then you return the integer which is a to the power of b. What to do? Very simple. You take an integer, maybe the power, a function, a product which will calculate this pow. So use that product, integer product, and using it I will keep on multiplying a b times. What is a to the power of b? If you really think of a to the power of b, the meaning of it is a into a into a into a, so on, b times. Please see this. Is not it so? So this is int product you take. Now you need a for loop for I equal to 1. So I has to be defined again. For I declared again, for I equal to 1, how many times? B times a need to be multiplied. So I less than equal to b, I plus plus. That is, this loop will iterate b times. Every time the a has to be multiplied with the product, which has to be again initialized to 1. Product initialized to 1. You multiply A with it. How many times? B times. You B times the loop iterates, A multiplied with 1, how many times? B times. So definitely it is A to the power of B. So product into equal to A. So your product is done now. What you do is, one line to end, return product. I think you understand, and this program is now calculating, this function is calculating POW. If you pass A and B to it, it calculates A to the power of B. If it receives A and B, it calculates A to the power of B. So if you send to it I and I plus 1, it will calculate I to the power of I plus 1 and return over here. Over here it will be returned. And again if you pass to it I plus 1 and I plus 2, it will calculate I plus 1 to the power of I plus 2, and where will it return? It will return here. You, instead of receiving those separately in different variables, I have directly multiplied them. The values which after returning I have directly multiplied, and after multiplying I have assigned it to sum. So your sum is done and the printf can be done. If you run the program, you can see it will run properly. If you run it for 2, it is 1 square into 2 cube plus 2 cube into 3 to the power of 4. So 1 square into 2 cube, it is 8, and 2 square into 3 to the power of 4. That is 2 square is 4. 3 to the power of 4 is how much? 81. Is not it so? So you calculate, it will work properly. I will just calculate it once. 1 square, if you write 2, I will show you. 1 square into 2 cube. 1 square is 1. 2 cube is 8. So this one is 8. This is 2 cube. This is 8. 3 to the power of 4. How much? 81. 81 into 8 makes it how much? 648. 81 into 8 makes it 648. 648 plus 8 makes it how much? 656. So your answer should be 656. Run it again. For 2, your answer is 656. If you run it for 3, definitely it will be a bigger program, 18,064. Is not it so? You can calculate for other numbers and you get what it is done. Now I will tell you, if suppose I did not write int POW, suppose this int POW was not there, will this work fine? If this int POW is not there, will this program run? Alt or enter? Definitely not. Function POW should have a prototype. Function POW should have a prototype. You have not defined POW. If you call a function, you must define it. Suppose I now get rid of this comment and keep math.h in the program. Program again runs fine. 2 shows 656 again. Why suddenly? POW is not there, POW is commented. How come POW started working without even the function being written? Because you included math.h and POW function is already there as a library in math.h header file. I repeat, math.h is a header file, and in that header file a library function POW is already written. So if you call it, that POW function is being called. Like when you say clear screen, the clear screen library function from conaio.h is called, which you include as a reason. You say getch, getch works. You have not written the getch function anywhere, but it works because getch is present as a library function in conaio.h. So I think you understand this. Here also POW works exactly in the same way because math.h contains the POW. Okay, so we will come back, we will take a bit of break over here, and we will come back with more interesting and more programs using functions. Thank you so much. We will meet after a break.